Now we're going to talk about another type of problem we can see with plurality voting called minimum number of votes needed to win. This is different from what we saw in the last video, which was minimum number of remaining votes. So here there's not any remaining votes. We just want to see what's the smallest number of votes a candidate can win a plurality election with. In these types of problems, you're going to be told that there are a certain number of candidates running in an election decided by plurality, and there's going to be a certain number of votes. Then they're going to ask you what's the smallest number of votes a candidate can win the election with. The general idea for solving these problems is divide the number of votes by the number of candidates to see how many votes each would get in a perfect tie. Usually there's going to be decimals that come out, so you're going to get rid of the decimals, pretend everybody has that number of votes. Then you're going to play around with the extra votes to determine the smallest number a candidate can win with. And the easiest way to see how this works is to look at an example. So let's see, here we are being told there's 6 candidates running an election that's going to be decided by plurality. If there are 386 votes, what is the minimum number of votes the winning candidate can receive? We have 386 votes, and we're going to divide this by 6 candidates. We do our division, and we end up getting 64.333. So what this tells us is that if each candidate gets 64 and 0.333 votes exactly, we're going to have a 6-way tie. But we know that we can't have 0.333 of a vote. You can have 64 votes or 65 votes or some other whole number of votes, but we can't have some decimal amount of votes like this. So what we're going to do to start off is we're going to give each of the 6 candidates 64 votes. And that's going to give us a total of 384 votes. If we have 384 votes total, and we needed 386 votes in the election, that means there's 2 votes we didn't count, so we have 2 extra. Now what we want to do is play around with these 2 extra votes to see what's the smallest number a candidate can win with. One possible thing that we could do is we could say, okay, well, let's give 1 vote to this candidate, 1 vote to that. Then we have 2 65s, and everybody else has 64. In this case, these guys end up tying, so that's not the smallest amount that a candidate could win with because they're tying. So what we'll have to do is give both votes to one candidate. We will give both votes to one candidate. They end up with 66. Everybody else ends up with 64. And now we have a total of 386 votes. So 66 votes is the minimum number of votes needed to win this election with plurality. It is possible to win this election with more than 66 votes, obviously, but 66 is the smallest number you can win with, and that would occur in a situation exactly like this one. Let's take a look at another example now. In this example, we now have 5 candidates, and we have 1,159 votes. We're being asked the same thing again. What is the minimum number of votes the winning candidate can receive? We're going to first take our number of votes and divide it by the number of candidates we have. This gives us 231.8. What this means is if we had a perfect situation where everybody could get 231.8 votes, we would have a perfect 5-way tie. But again, that can't happen, so we're going to give everybody 231 votes, see how many that adds up to, see how many extra votes there are, play around with the extra votes, and give the extra votes to the winner, or some number of the extra votes to the winner. Here we have, these are our 5 candidates. They each get 231 votes, and if everybody gets 231 votes, our total is going to be 1,155. What this means is there are 4 extra votes we have to play around with if we want to get up to 1,159 votes, which is the number of votes that we started with. Now, what we could do is there's a few different ways we could play around with this. Obviously, if we do something like, adding +1 across like this is just going to create a 4-way tie at the top. where we have 232, 232, 232, 232, 231. That's not good. From this, we know that our winning candidate obviously is going to need more than one of the extra votes. So we'll get rid of all this. Now let's try giving 2 of the extra votes to one of the candidates. So we'll give this candidate 2 votes. Now what we could do is give 1 vote to this candidate and 1 vote to that candidate. So now we have 233, we have 232, 232, 231, 231, and 231. And all of these add up to a total of 1,159. So the minimum number of votes the candidate could win this election with is 233. Here's another problem. What I'd recommend doing now is pausing the video and trying to solve this one yourself. You would solve this one similarly to how we solved the previous 2 examples. When you finish it, continue the video, and then you'll be able to see my version of the solution. In this problem, we have 915 votes, and we have 6 candidates. We're going to start this off the same way we started the last 2 off. We divide our number of votes by our number of candidates, and we end up with 152.5. So what this tells us is if each of the 6 candidates had 152.5 votes, we would have a perfect 6-way tie. But we can't give people 0.5 of a vote, so everybody's going to start off with 152 votes, and then we'll see how many extras there are. So we have 152 6 times. And if we add all of these guys up, that gives us a total of 912 votes, which means we have 3 extra votes. So these 3 extra votes we need to play around with. You may have tried a few different things. The solution that works, or to get the smallest number of winning votes, is if we add 2 of the extra votes to one candidate and then 1 of the extra votes to another candidate. This will give us 154, 153, and a bunch of 152s. So 154 is the minimum number of votes needed to win this election with plurality. Now we'll talk about some problems with the plurality method for voting. One problem is sometimes there is no popular choice. A popular choice is a candidate that wins with the majority or more than half of the votes. So if you see this word majority come up in any problems or anywhere in your textbook, what this means is more than half of the votes, so at least a little bit more than half. So not 50%, slightly more than 50%. Another problem that can arise because of situations like this is voters may not vote for the candidate that they prefer most in an attempt to improve the outcome of the election from their own point of view. This is called strategic voting. You may have also heard the term voting for the lesser of 2 evils. Let's say you have candidates A, B, and C. And based on polling reports on the news, you know candidates A and candidates B are the ones that have the most likely chance of winning the election. Your favorite candidate is C, but their poll numbers are terrible and people do not think they are going to win. It's down to just A or B, and let's say you don't like A, you don't like B, but you think A is really, really horrible and you think B is slightly less horrible, so you end up voting for B. These are things that happen with plurality elections. We can also have situations like this that come up in real life where you have, let's say 6 candidates running in an election. You have it very evenly split and you have somebody win with this many votes. That's, you have more than half of the people here, a vast number of people who voted in this election are not happy with the election's outcome. These are things that can happen with plurality. Now we'll look at some examples concerning finding the minimum majority of votes, or the smallest number of votes a candidate can win an election with if they have to win the election with the majority. Let's look at this first example. If 250 votes are cast in an election, what is the smallest number of votes a candidate can win the election with if they must win, win, with a majority? We know majority means slightly more than half. What we would do here is take our 250 votes. If we divide this by 2, we end up getting 125. So 125 votes is exactly half. So if a candidate needs to win a plurality election with the majority, slightly more than half would be 126. Let's look at the next example. If we have 99 votes in an election, what is the smallest number of votes a candidate can win, and these should say plurality election, if they can win an election with, if they must win with a majority? Again, we would do this the same way as the last example. We take our number of votes, we divide it in half. So we divide 99 by 2, and we end up seeing 49.5 is exactly half. Now you can't have 0.5 of a vote anyway, so we would go up to 50 is slightly more than half. 50 votes would be the minimum majority in this election.